So let's use the initial rate method on a pretty straightforward example here. So what are we testing between experiments 1 and 2? Well, what changes? It's the concentration of hydroxide. So when we compare rates between experiments 1 and 2, we're going to find the order of hydroxide. And what did we do to the concentration? Well, it's pretty clear we exactly doubled it and went from 0.04 to 0.08. And what does that do to the rate? It goes from 2.2 times 10 to the fourth to 4.5 times 10 to the fourth. Now that's not exactly doubling it, but it's pretty close enough to just say, yeah, that's pretty much doubled. So we change the concentration of hydroxide by some factor, and it changes the initial rate by the same factor. And that factor is the factor of 2, since it gets doubled. So the fact that we see the same factor of change for the concentration and the rate means that this is a first order reactant. So N equals 1. Now for those of you who are mathy and like equations, here's a foolproof method to mathematically approach finding orders. So the trick is to just divide the whole rate law equation for experiment 2 by the whole rate law equation for experiment 1. We can do this because we can do anything we want to an equation so long as we do the same thing to both sides. And we're dividing the left side by what is, by definition, the same as the thing we're dividing the right side by. But the point of this is to get a simplified equation. We can cancel out anything that doesn't change. So K is a constant, it doesn't change. And we didn't change the concentration of this stuff between experiments 1 and 2. So that cancels out, and we're left with this. After the cancellations, this is what we're left with, and we can write this a little differently, like such. And then we can just put in our numbers and solve for n. And what this really is 2 equals 2 to the n. And it's pretty apparent in this case that n equals 1. But we still have to find the order of the methyl acetate, our other reactant. So which experiments should we compare to figure that out? Well, they need to be 2 experiments where the concentration of methyl acetate is the only thing that changes. So it looks like the hydroxide is the same between 2 and 3, and the methyl acetate doubles. And again, the rate doubles as well as the concentration. So we have the same thing going on for the methyl acetate. Both the concentration and rate are changing by the same factor, a factor of 2. So this is a first order reactant. So M equals 1 as well as N. And if you wanted to know the total order, it would be the sum of all the orders. So if there was 3 reactants, we'd add all 3 of the orders together. Here there's only 2. So we could call this a second order reaction.